Let us now understand how do you represent a set. There are basically two ways in which you can represent a set. One is called the tabular form, or sometimes also referred to as the roster form. The other one is basically your set builder form. Now a tabular form is basically when you list down all the individual elements of a set. List all individuals of a set. And when I say individual, I mean individual elements of a set. So in our previous example, we saw even number less than 2, 10. Right? So what I do is I find out all the even numbers which are less than 10. Suppose you are told that Z is equal to even numbers less than 10. Now there are two ways in which you can write this. Okay? Now I can either write what all are the even numbers which are less than 10, which is nothing but 2, 4, 6, 8. So when I write all the individual elements of a set, it is known as the roster form or the tabular form. So whatever were the numbers, I put it down here. Now this could be easy when there are the number of elements are less. However, if I were to ask you, please write down even number less than 10,000, then writing all these numbers might be difficult. Well, in any case, we are not considering that at this point. So when you write down each the elements of an individual set, you get the tabular or the roster form. Now how about this set builder form? A set builder form basically is nothing but what? It's kind of a definition which defines the element of a set. Okay? So what happens is that all the elements in a set builder form, let's say, let me take an example. In a set builder form, what happens is that, let's take an example, prime numbers less than 10. So in this case, we know what are the prime numbers before less than 10, which have 1, 2, 3, 5 and 7. So let us say this prime number set is denoted by x. So we say x is equal to 1, 2, 3 and 5 and 7. Now if I write it in this form, this is nothing but the roster form. But I need to put it in a set builder form. So once you have to do it in a set builder form, you write it in the form, let's say a is equal to x such that x is whatever. This is the generalization that you do. So in our case, we have a set called x. Please note that whenever you have something in a set builder form, whatever is the property of each of these numbers that cannot be for any other number outside this set. So let's say, let's take a prime number 11. Will 11 satisfy this definition, prime numbers less than 10? The answer is no. So there would be no number which will be less than 10 which falls outside this set. So basically in such a case you define this as the name of the set, which could be anything. Let's say we took it as x. X is equal to, now x is basically a value which is possessed by all these numbers. The property has to be true for all these numbers. So we say x is a set such that x is an element of this set. Then we put in a semicolon. This semicolon is read as such that. So you say x is equal to x, which is an element of a set such that x is a prime number less than 10. So what you do is you put in a definition for the values which are here, and that you have to identify as to what are the values which are here, right? So the difference is here you list out individual elements, here you make a definition. Now in this case, please note that each of the elements which are coming in here appears only once. So let's say if you had the letter America and you were told to write down the set of the alphabets contained in America, you would write it A-M-E-R-I-C. You will not repeat this. Now the order in which you write these really don't matter. You can also write this as M-E-A-C-I-R or any other form. The order does not matter when you write it in a roster form. So that's about the representation of a set. As we do some examples, you will get a more hang of this.